Welcome to the lecture on Numpy. In this lecture, we are going to look at what number library is about and what we'll be seeing how we can use the number library to do some numerical operations on it so that it will come in handy in our upcoming lectures. So here we are going to introduce you to the Numpy library. Basically, Numpy is a Python package and it stands for numerical Python. Also, it is a fundamental package for numerical computations in Python. So if you want to perform any numerical operations, that NumPy library will be used, and it supports n-dimensional array objects that can be used for like processing multi-dimensional data, and it supports different data types. So in previous lectures, we already seen about Python arrays. So for just recall purpose, an array is just a data structure that stores values of same data type. So if you are creating an array, then all the elements in the array should be of same data type. So we have also seen another container called list, which can contain values corresponding to the different data types. But arrays in Python can only contain values corresponding to the same data. So we have already been introduced to like what Python arrays are. So in this lecture, we are going to discuss about the advantages of using NumPy array. So NumPy array is a grid of values, all of the same data type, and is indexed by a subtuple of non-negative integers. NumPy is one of the core libraries for scientific computing in Python, and also provides a high performance multi-dimensional array object, and using NumPy mathematical and logical operations on arrays can be performed. So you can say that is why we prefer using the NumPy arrays over built-in arrays in the Python. So in the Python, the number of dimensions of the array is called as the rank of the array, and a tuple of integers giving the size of array along each dimension is known as shape of the array. So once you have an array with you, if you want to look at the shape of it, and then it is going to give you a tuple of integers giving the size of the array along with each dimension. As we know that NumPy provides a high performance multi-dimensional array object, so elements in NumPy arrays are accessed using the square brackets like the other arrays, and it can be initialized by using the nested Python list. So now let's see some practical aspects of NumPy, that how we install NumPy in Anaconda Jupyter Notebook, then how to use NumPy, and the various things that we have discussed, that is rank and shape. So let's do some practical about NumPy. So there are several ways to create arrays. For example, you can create an array from a regular Python list or tuple using the array function. So here I am creating a list which contains the values ranging from 1 to 6, and the name of the list is my list, and you can see the output that the values are enclosed inside the square brackets. So to create a NumPy array, we first need to simply import the NumPy package, and also to import we need to first install the NumPy library on our machine. So for that we need to run a command, that is pip install NumPy. Just remember one thing, when you run this command, that is pip install NumPy, after that you need to restart the kernel. When you click on it, when you run this command, you will get a message that requirement already satisfied and you may need to restart the kernel. So for restarting the kernel, you just go here and restart the kernel. So restart, so that it will work properly. So now after like installing Numpy, what you need to do, this is the first command. So this is giving this output. Then no, you need to install the Numpy. For installing Numpy, you just need to write pip install Numpy and run this command. It will take some time to install Numpy. Then it will display some messages regarding the Numpy. So see now it is installed. So you need to restart the kernel to use the updated packages. So after that, now that I have installed the Numpy on my machine, so you need to create Numpy array, and for creation of Numpy array, we first need to import the Numpy package. So for that, I need to use import command, that is import Numpy, and here I have imported it as np, and I am just using np dot array, and here you can see np dot array is used, and the basic n dimensional array is created using an array function in Numpy. So here I am using the array function from Numpy library, and every Numpy array is a grid of elements of the same type. So you can see here. Numpy provides a large set of numeric data types that you can use to construct arrays. So you can say Numpy tries to get a data type when you create an array, but the function construct erased usually also include an optional argument for to explicitly specify the data type. So if you can see here, the first argument to the array function is my list, which has a list of values from 1 to 6, and the next argument is d type, which is equal to integers, which specify that I am going to create an array with the data type integer. And suppose if you are not providing anything, so it will automatically guess a data type, and when you create an array itself. But if you want to explicitly specify the type, then you need to do this, like d type and the type of the values. So here I am creating an array using the array function from Numpy, and I'm just printing it. So just you can see array is created here with the help of the array function. So now after printing this, what I'm going to do here, I am printing the type of array. So this basically gives you to the data type of the object, and if you printed the output is class Numpy dot and array, because Numpy's main object is the homogeneous multi-dimensional array, and it will give you the type of array dot and array irrespective of the dimensions of your array. So the next thing is to learn about the length of array. So for that we have used a function, that is len, which is going to give you the total number of elements present in the array. So here you can see total number of elements in array is 6, and you can also get the number of x's of the array by giving the ndim command for ndim property, which is basically stands for number of dimensions of the array, and it says 1 because you have only one dimension to it, that it means that you have only one access to your array. So now let me just check dimension of the array. So for that array, checking the dimension of array is going to give you an output of tuple of integers, including the size of array in each dimension. We know the dimension of array here is 1, and let us just check the size along with each dimension. So you can see automatically you will have a vector when you create an array. So you will have 6 rows with 1 column, that is where you have 6 and nothing. And about the shape, that is shape of an array can be changed with various commands. So here I am going to use a shape or a reshape function that is going to be used to reshape your array. But you know that following command will return only your modified array, and but it is not going to change the original array as well. So let us see that how to reshape the array or how to use reshape function. So here you can see 3 comma 2 is represents, it is going to reshape the column with 3 rows and with 2 columns. So I have reshaped the array which has 3 rows and 2 columns. So now after reshaping it, if you check the size of array, it is going to give you the output as 3 comma 2. So we have reshaped the array as for the dimension 3 comma 2. So but if a dimension is given as -1 in a reshaping operation, like the example that I have given, then the other dimensions are automatically recalculated. So because the 3, that is, you can see here the 3, the first argument 3 represents that how many number of it should have the, and the -1 represents the other dimension is going to be calculated automatically by the Numpy library, because this is basically just an example that is to illustrate that how the arrays are created and how we can perform some operations on arrays. So but if you are if you are dealing with large set of arrays, then in that case you are not sure about the dimensions of your array. So then if you just want to reshape it, so according to your desired dimension, then you can just use -1 as any of the dimension. So because in order to use reshape, at least you should be specifying by specifying one dimension exactly, and the other dimension can be calculated automatically by using the Numpy array. So here I have fixed -1 along the column dimension. So you will have 3 rows and 2 columns, and this has been calculated according to the size of your array. So you can say basically it depends on the number of elements that array consists of. So since I have 6 values, I have just given it as 3. So now let's see that how to initialize Numpy arrays from nested Python list. So now you can see here, initially we had only one list as an argument to the number array, but here I'm going to create an entire array from the nested Python list, and for that I have created 3 sets of lists having few numbers to it. So I have 3 lists. The list name is my list 2, 3 and 4, and I'm using the array function from Numpy library, and inside that I am going to give list of list as the elements that needs to be passed in as an argument. So if you can see here, my list itself is a list, and I have given 3 lists and then given the square brackets outside of it, and inside the list also I have 3 lists. So if you just print it, it is going to give you the output like in this way. So you have created an array called mul underscore arr, which has some values to it. So if you check the shape of it, so for that I have written here like mul underscore arr dot shape. So it gives you 3 comma 5, that means 3 rows with 5 columns, and you should be able to reshape your multi-dimensional array as well using the reshape function. And here I am just reshaping the multi-dimensional array as 1 comma 15, so that I can have the array values in a single row with 15 separate columns. So you can see the output like this way. So now we are going to discuss some NumPy attributes that you can fetch from your NumPy. So here you can see I have just created a array called A, which has two lists to it. So it has 2 rows and 3 columns. That is the shape of array. The shape is one of the attribute. As I have already told you that there are several ways or several commands that can be used to reshape the array. But here I have given you an example on that how to reshape the array using the reshape function. So another method which you can use to reshape the n-dimensional array is like can be a dot shape, which basically gives you the dimension of array, and I am just passing a tuple which contains some integers which also describes the dimension of array as the input. So here you can see I have reshaped an array with the dimension 3, 2. So you can see the reshaped array is shown here, and I am also mentioned that how to reshape the array using the reshape function using this command. So here I am using a shape function, whereas here I am using the reshape function. So for resizing the array. So you can see outputs are same for both functions. So now you can see if like you can say you will also be able to create a sequence of values and then created as an array using the range function. So I have given a range of 24. So it is going to give me a sequence of values starting from 0 to 24. So, but the downside to use the range function is you would not be able to see what are the values that are there like under the created range. It is just going to return the range of values like 0 to 24 as an output when you try to print the R. So the range function is often used when you are dealing with control structures, and if you want to iterate a value with a given sequence of values, using range in that case, range will be very helpful. But to create a sequence of values, we can use a function called arrange from the NumPy library. So here you can see an array of evenly spaced numbers. For that I have used arrange. So it is called as a range because from NumPy it is going to create an array based on the sequence of values that you have given as an input, but it is going to return an array. That is why the function name itself is a range. So the arrange function syntax, the start value, stop value, and then the incremental value. So it is basically takes in 3 arguments. I have just given only one argument. You can see here. So by default, it is going to take that value as a stop value, and if you are not given any start value, it is going to start from 0. And by default, it is going to increment the value, but number 1, I have given 24 here, but you would have got till 23. That describes that stock value, whatever I have given here, it will return 1 minus like the value, that is 23. So here I am providing 24, but it is giving 23. So if you check the dimension by using the ndim command, ndim property, then you are having the value 1 here. Now next we are having, suppose if you can see here, this is the original array and I am just wrapping the array as a given 6 as the first argument. It is going to keep all the values into 6 vectors, and each vector will have the size 4. One under each vector you will have values in 4 rows, and with single column from 0 to 3 is a vector. And also it has a dimension 4 cross 1, and the second vector also has 4 values to it in a single column. So similarly in other vectors you can see here. So you can see I have given the first dimension as number of vectors it should have, or under each vector what is the size, that is 4. One that represents the number of rows and the number of columns that you are going to use to reshape the array. So this is how we can reshape the array using the reshape function. So now let's perform some arithmetic operations on Numpy arrays. So I have created two arrays here, and the elements inside the x and y arrays are of float 64, and you can perform some of the arithmetic operations like addition, subtraction, multiplication and division. So let us take an example. So using these values, when you print these values, you will get these values as. So now there are two methods for adding these two arrays. The first is you can directly write just print x plus y, and the second method is just you need to provide parameters within the add function. So you can write np.add, and in brackets you have to write x comma y, and the results for both will be same. Same way you can perform subtraction. For that you need to write x minus y, otherwise you need to write the function name, that is subtract. Similarly you can perform multiplication by the multiply sign, that is asterisk, or you can write the multiply and x comma y. So simply you can get the values. So now if you want to get the dot product of two arrays, then you can use the function called dot x. Dot of y is going to give you the dot product of two arrays x and y, and you can use the dot function either by applying it on one array or then using it on the other array, or you can just use np dot dot, and inside the function you can just give the two desired arrays that needs to be multiplied, that values to be multiplied. And similarly you can perform the divide operation between two arrays, that is x and y, by using the slash operator or by using the divide function. So here from the Numpy libraries, so all of the addition, subtraction, multiplication and division using the required commands is going to do the element wise operation between two arrays. So in last you can see these three commands that I have tried, which basically first used to compute sum of all the elements. Second is it will compute all the sum of each column, and the last one is sum of each row. It will show you